In 8.1, number 5, we're given the reading speed of second grade students in a large city is approximately normal with a mean of 92 words per minute and a standard deviation of 10 words per minute. What is the probability a randomly selected student in the city will read more than 97 words per minute? So since we have this normal distribution, we can use your normal calculator. And we can just calculate this probability by putting in our mean of 92 and our standard deviation of 10 words per minute. And we're determining the probability that one student reads more than 97 words per minute. So we're analyzing this x value is going to be 97. The probability is over here. So the area under the curve, our probability, is always in this box. Your x value is in this box. And in this case, our x value is words per minute. So we have that this probability, we want to round to 4. So I'm just going to copy and paste. This probability is 0.3085. So interpreting this probability, instead of one student, if 100 different students were chosen from this population, how many would we expect to read more than 97 words per minute? And so we can just take this probability and multiply by 100. In other words, move your decimal 2 places to the right. And I'll round that, instead of 30.85, I'll round that to 31 people. So we would expect 31 to read more than 97 words per minute. And the reason I know it's more than is because that's what I analyzed in this problem as well. Okay, part B, what is the probability that a random sample of 11 second grade students from the city result in a mean reading rate of more than 97 words per minute? So the only thing that changed here is our sample. So we were just analyzing one student in part A. We just used your normal calculator, just like in section 7.1 and 7.2 and 7.3. The difference here in section 8.1 is that we're analyzing samples. And so that's when the central limit theorem applies. Instead of analyzing one person, we're analyzing this sample of size 11. So from your 8.1 notes in the central limit theorem, we learned that the mean of the sample means is the same as the population mean. That means the average of the averages is the population average. So that sounds a little bit confusing, but the mean of your population, which was 92, it still is going to be that same mean for this sample of size 11. But your standard deviation changes, and we call this standard error. So your new standard deviation or standard error, this formula is in 8.1. You take the standard deviation of the population, which was given to be 10, and you divide it by the square root of your sample size. And our sample is now size 11. So 3.015, that is my new standard deviation. The rest of my problem is the same. We're still analyzing if the probability that these students can read more than 97 words per minute. So I'm going to copy this probability over. Okay, and now let's interpret. So if 100 independent samples of size 11 students were chosen from this population, how many would we expect to have a sample mean reading rate of more than 97 words per minute? So again, we're just multiplying this times 100, so that's going to be 4.86, or I'll say about 5. So out of these samples of size 11, we would expect 5 of those samples to have this reading rate of 97 words per minute or more. Okay, part C, what is the probability that a random sample of 22 second grade students from the city result in a mean reading rate of more than 97 words per minute? So just like in part B, the only thing that has changed here is our sample size. We now have a sample of size 22. And so the mean of this new sample is going to stay the same. The standard deviation changes, and using your formula from 8.1 or the central limit theorem, take your standard deviation of the population, divide by the square root of the sample size. That is your new standard deviation of this particular sample. So that is 2.132. Everything else in your problem stays the same. We're still analyzing greater than 97 words per minute. Okay, analyzing this, if we had 100 samples of size 22 students chosen from this population, we would expect about, I'm multiplying this times 100, so 0.95, I'm going to round 0.95 to 1. We would expect one sample to have a sample mean reading rate of more than 97 words per minute. So again, I just took this probability and I multiplied by 100 because that's how many independent samples we are choosing. Okay, so part D, what effect does increasing the sample size have on the probability? So we went from a sample of size 1 to a sample of size 11 second grade students to a sample of size 22, and the probability it decreased. It went from 0.3 to 0.04 to 0.00. And so you can see that the probability is decreasing as your sample size is increasing. So let's interpret that. So increasing the sample size decreases the probability because this is your standard error. Sigma sub x bar is called your standard error. That's what this value was. Your standard error was decreasing as your sample size n was increasing. Okay, as the samples got larger, the probability got smaller. That was because your standard deviation was getting smaller as n was getting larger. Okay, so now a teacher instituted a new reading program at school. After 10 weeks in the program, it was found that the mean reading speed of a random sample of 19 second grade students was 94.4 words per minute. What might you conclude based on this result? So first, let's just figure out what we have and how we can use that in StatCrunch. So we now have a sample of size 19 students, and their reading rate was 94.4 words per minute. So I'm looking at what my answer choices are so that I know how I can type this information in. It says a mean reading rate of 94.4 words per minute is either unusual or it's not unusual, since the probability of obtaining a result of 94.4 words per minute or more is blank. So we're looking for this probability. And remember, this is probability. So this is what we're looking for right here. And we are analyzing 94.4 words per minute or more. So interpreting that into StatCrunch would be probability x is greater than or equal to 94.4. Now my mean has stayed the same because our mean of this sample of size 19 is still going to be the same as the population average or mean, but the standard deviation changes. So to find our standard deviation, take your standard deviation of the population. Again, that was 10. That was given in the original problem. Divide by the square root. Oops. Let's try that again. Divide by the square root of your sample size. In this problem, that was 19. So I'm typing this in for my standard deviation. Okay, so my probability in this group of students of reading more than 94.4 words per minute is 0.1477. And now we have to figure out if our answer is A or B. I'm going to say that this is not unusual because the probability is greater than 0.05 or 5%. So my interpretation is that reading rate is not unusual. So we would expect a mean reading rate of 94.4 or higher from a population whose mean reading rate is 92 in how many of every 100 students, 100 samples of size 19 students. So again, we're multiplying this probability times 100, and that's 14.7. So I'm going to round that to about 15. And so this says the new program is not abundantly more effective than the old program. Okay, and the last part of this problem, there is a 5% chance that the mean reading speed of a random sample of 23 second grade students will exceed what value? Okay, so they've changed things a little bit on us. They're giving us this probability of 5%. And remember, probability goes over here. So I'm going to type in 5%, or as a decimal, that's 0.05. So I know the probability, but I do not know the words per minute that they're reading. That's what we're looking for here. Okay, and my sample size is 23. So the mean stays the same as the population mean, but my standard deviation changes since my sample size changed. So again, through the same process, 10 divided by the square root of your sample size. That gives us our new standard deviation. Okay, and so now we have the words per minute. So there's a 5% chance that the mean reading speed of a random sample of 23 second grade students will exceed, and that's greater than or equal to, means exceed. So it will exceed 95.43 words per minute.